Good morning, everybody. Thank you for showing up early today. So we'll talk a little bit about the extension we have done to simplify the configuration, both deployment and lifecycle management for NFV-specific configuration, and kind of the methodology and approach we had to the solution, which we hope can be applicable to other type of the workload. Most of the work were done by Sumit and John Pierre, but they are not here today, so on their behalf, Chris and I will present the work mostly implemented by them.
Yeah, so I'm Chris Janiszewski. I'm the OpenStack solution architect at Red Hat. As Arkady mentioned, most of the work has been done by a Dell team, so I really appreciate them allowing me to tag along. So what solution architect is, I go to the customers in North America and I perform OpenStack discovery sessions and etc. And then take the knowledge that I learned, translate some of the business use cases into the solutions using the OpenStack most of the time. I'm definitely a TripleO expert. I feel like as good as almost like Steve Hardy. I think I've probably done. I have over 100 TripleO deployments under my belt. So let's talk about what are the typical network function virtualization requirements from the platform perspective. So the customer I talk to, the number one thing they're looking for speed, and you can take the speed from multiple angles. Speed in terms of they're looking for the platform that's fast moving. So they're looking to take advantage of the features that OpenStack brings in with every new release, things like DPDK and SRIOV. But also you can look at the speed from the angle of they need these NFV, the VNFs that they're deployed to be working really fast, especially in the networking space. They're also looking to automate it better. Like TripleO does a really good job, with the lifecycle and deployment of the OpenStack. But there's more work and more enhancements that can be done. Automating the deployment itself, and also maybe execution of the VNFs with the day 0, day 1 configuration to the OpenStack. They usually ask for the platform to be open, right? That's why they picked OpenStack, and of course it's got to be cost effective. So first I'm going to state what type of problem we're trying to solve with this solution between Red Hat and Dell. So there's a couple issues that I want to go a little bit deeper into, and then and explain them a little bit better. So one of the issues is that your typical x86 server comes with the dual socket configuration, right? And these two sockets are connected with some sort of interconnect in between them, with the Intel, for instance, the QPI. And if you deploy a VM or the VNF on that compute host with the dual socket and not configure anything, just let it use its default thing, there's a very good chance it's going to try to use the CPUs from two different sockets, right? So it's going to try to allocate some of the CPUs from one socket and some of the CPUs on another socket. And obviously, every time you have to go through that QPI link between the two sockets, you add some overhead to your performance. So that's one of the issues we're trying to solve here. There's also the whole concept of the physical NICs being connected to the bus on either of the sockets, right? So if your VM is using the socket, in this example on the right side, socket 1, and your NICs are attached to the socket 0, that communication has to go all over here for the memory and the QPI. So it's not optimal. So that's one of the things we are show you how we fixed with automated deployment. And also there's the whole concept of the memory translation between page and frame, right? So your virtual memory into the physical memory. So there's some limitation. There's a concept of the TLB, which is like a caching system that allows you to do the quick translation from the page to frame. But however, this caching is also limited. So there's a concept of the huge pages where you can minimize the impact to the TLB and just create your pages to be much larger. So this is one of the solutions that, from the strictly OpenStack perspective, you can provide. You can just pin the application to run on a course on a specific socket, and this way you don't have to. If you remember the other picture, you would have to go all the way for the QPI. In this case, you're connected directly to your NICs, which is going to improve performance. There's also some other challenges that we're solving with OpenStack with TripleO, and that is using the standard OVS for your networking. And the standard OVS has a 2 layers. There's a kernel module that runs in the kernel layer, and then there's a namespace layer as well. And that can it gives us a lot of flexibility of using a lot of functionality of this Open vSwitch, but it adds latency to it as well. So there's multiple solutions to that problem we're implementing in the TripleO, and that is you can either use something that's called SRIOV, where you pass through your NIC directly to your VNFs, and this way you get almost bare metal performance with that. Or there's a concept of the OVS DPDK where everything runs in the user space rather than going down to the kernel space. There's some other problems that we're trying to solve to improve from the performance perspective for the NFV platform, and I listed them here. And we mentioned huge pages and CPU pinning, SRIOV and OVS DPDK. I listed a couple more out there that we can also work with the lifecycle management to take advantage of some of the other improvements there. So between Red Hat and Dell, this is the diagram that we put together for how this solution would look like between the two partners. So this might look familiar if you are already deploying NFV. So you can see there's a NFV infrastructure layer in the middle. Above, these are all the VNFs. And I think Red Hat is now, as far as I know, 31 certified VNFs that can be run here. And we integrate your virtual compute, virtual storage, and network with these solutions. All right, so why would you pick Red Hat OpenStack platform or TripleO? What are the benefits really of using this solution rather than something else? So I think the biggest selling point for me usually is the flexibility of the deployment and lifecycle. So anything, there's very little you won't be able to do with TripleO. It's definitely extensive, and it's not designed just for the cookie cutter deployment. So if you're looking to get into these advanced features like SRIOV, DPDK, there's no problem whatsoever to do it with the TripleO. So there's a lot of feature set that's already built in. We support the in-place upgrades since OSP 7, at least from the TripleO perspective. And I can tell you, I'm doing these upgrades quite often, and I can tell you the process improved tremendously. The OSP 10 to OSP 11 add some Ansible enhancement to it, and it's really smooth. And of course, the TripleO is part of the bigger OpenStack project, right? From the business perspective, why would you care about picking the TripleO? Is we have the best partner ecosystem there is. We partner with folks like Dell, SDN vendors, storage vendors, etc. So you have a variety of people that we can work with. Of course, the enterprise support. We own the entire stack, right? So Red Hat, as you might know, was known mostly from the Linux initially. And then we move up in the stack, and we pretty much own every component in the deployment, including things like Ceph and virtualization, et cetera. And we have the really good know-how. We are very fortunate to work with a lot of telcos in North America and beyond. So we're able to help you deliver what you need to deliver. All right, and why Red Hat and Dell? You know, Dell is the #1 server manufacturer, and they create best-in-class hardware. They're also one of our distributed continued integration partner. What it means is they have access directly to our repositories, the pre-release packages, and they can continuously test Red Hat OpenStack on their hardware. They're big OpenStack and Linux contributor, and what Arkady is going to talk about is how they're enhancing the lifecycle management with the Dell Jetpack. You can also buy a turnkey solution so that we can pre-configure everything for you. And we have this single vendor approach support. So if you have problems with either hardware or software, you only call one company and we handle the whole thing. And with that, I'm going to turn it to Arkady to cover the real meat of this presentation. Thank you.
Thank you. So when we started the NFV specific extension, we already had quite a bit of experience from our joint solution, which we had for about 4 years by now, and that we had the TripleO-based implementation. Then in order to be able to simplify and automate the deployment on setting up all of the various configuration files for TripleO, and also able to extend some of the things which we needed for the hardware configuration beyond what currently is available in Ironic. We had a kind of layer above, which we call the Jetpack, which kind of lets us do in deployment lifecycle management faster, but allows us to have a clean layer above it, so we don't need to modify the existing code base for OSP or for Ceph or various other components which make our solution, so we can support it in the field in a manageable way. So the thing which we're going to talk about, this is actually part of the solution which we are delivering jointly with between Dell, AMC, and Red Hat in the December timeframe. So this is not just a prototype. It is something which we deliver to the customers. So what is the approach we have taken? Well, first of all, we were a little bit constrained of what we were capable of doing, and the reason for that is that we're trying to deliver it in the field right now, and because the customer base who are interested in NFV primarily interested in long-term support for the solution, we were bound to the OSP 10-based code base. And we were trying to extend that, so we were not able to take advantage of several of the features which were available in the later version of the upstream code base and some of the features which were there. But it does not prevent us from using the methodology which TripleO delivered to us so we can do our work. So all of the work, not surprising, is in open source in this, oh, sorry. Oh, man. In the DSP Jetpack, which is a common repository we have been working for several years with Red Hat to make the optimization. So both our development team and the QA team can operate faster, and also we can deliver simplified management to the customers. When we looked at the approach, what we wanted to do, we decided that the best way of doing it, we kind of go layer by layer. So first we said, okay, we need the methodology so we are able to deliver the solution which is optimized for a specific use case. In our use case was NFV. As Chris looked down the list, here is a list of the features from the kernel and OpenStack point of view, which we need to configure. And not surprising, in order to take advantage of some of those features, we actually need to turn on some of the hardware acceleration to be able to take advantage of that, so BIOS setting and so on. Not all of those things are exposed in Ironic to be able to take advantage of, nor exposed in TripleO to take advantage of, and that's kind of the reason why we kind of went through the Jetpack, because it's a layer above, allows us to do clean abstraction and extend that without doing a modification to existing code base, which is questionable how we'll be able to support in the field. So based upon the profile, and the profile includes all of the node of various types, not just the compute part, but what the storage is, the controllers and so on will be able to do, and kind of combine them into what we call the profile of the solution, which will be automatically deployed on all of the node, configure the node what it's need to do. But for NFV specifically, we created a new custom role. Thank God for all of the work for our TripleO team, who was able to provide us ability to do that. And we created a new custom role. We called it Dell NFV Compute, because it was primarily for the compute where we needed a new extension. The others, we can utilize the existing role. And again, thanks to a lot of the work which TripleO team have done, we could expose the new configuration and the features we have done through the UI, because as soon as you have the right configuration, it will automatically expose the menu. Based upon experience we have done, we realized a couple of small things. One is we need a database, so we store what are the features on which node those features are being done, or specifically which roles being installed. And even within the role, since you can actually override and create other services for that role, to ability to know where the roles are, so you can go and do the appropriate hints in ANOVA in order to do the scheduling automatically on the right nodes. And then we followed the standard model. We extended the HIT templates. We extended TripleO to expose all of those. We have not completed the work for the support for upgrade and update, but we use this methodology to do kind of day N extension, where we can add the nodes to the solution and make sure that the right configuration lands on them. So from the delivery model point of view, there is 3 different areas which impacted by us trying to extend the things. There'll be the first one I'll mention in a minute. So the first one, if you wanted to turn on the huge pages as well as the NUMA, there are 2 separate services in our development. What you need to do is you need to go and turn the kernel features. Well, we looked at the 2 different ways we can do it, and we decided the easiest way for us to do is to go post deployment, but before we turn, post deployment of the node, but before we turn on post deployment feature of the OSP and turn on the kernel versions. And we kind of did expose it through the automation file as well through UI file to go turn them on. And then you specify what the feature, the huge pages, how many of them, and the flavor, and similar for CPU, which CPUs you want to pin. So that, to us, was a little bit ugly, but the real reason for why we have went that route is because in order to turn those features on in the kernel, we need to reboot the kernel after we have done it. And we wanted to do that before we load all of the OpenStack configuration in that. We looked at the alternative way of doing that, which is go take the overcloud image and change the image so all of those features are turned within the image and create a specialized image for the role. We are not quite sure what's the right way, so we viewed that as a kind of initial prototype, and that was simpler for us to do than cracking the image. If people have other opinion or have, what's a better way, we are all ears. But the goal is that it will be extendable for other templates and other roles. So we wanted to make sure that we go into the direction which makes it feasible for us to extend. So once the kernel is configured correctly for the features we need, the next step we need to do, we need to set up all of the configuration files for TripleO to use for the services for the role. So all of that was coded with a Jetpack, and that's part of Jetpack codebase in the separate branch. And then finally, all of the management of setting up the role is done through the hit templates as expected through the TripleO model. So I think I already mentioned all of that. I do want to mention that before we kind of started doing the configuration, we have obviously done the work of prototyping what the right configuration is supposed to be. And those are the features which Chris mentioned for NFV. We have done similar work for the Hadoop. We are working similar work for HPC to identify what are the right configuration for kernel, for the hardware configuration, and for the OpenStack features before we start figuring out what do we need to automate to do the configuration. As I mentioned, we created a new custom role. We called it Dell NFV Compute, and then you can pick up any name you prefer to. We followed the bare metal node and extended 2 services for that, which comes with the role. One thing which we looked at and were not able to find any better way of doing it was that how do we pick up a node which has the features configured for that. And there is no mechanism to extract the role configuration, so the only thing we were able to do is kind of follow the model which we have seen in a couple of examples where it's based upon the name. So based upon the name of the role, you know, okay, this is the role which is on that node and that has that features, but there's no way to go down and figure out what the actual features are turned on. That's not in existence yet. I don't know if it makes sense to extend it or the current naming convention would be sufficient going forward, but that's one of the smaller interesting things we bumped into. Network configuration, we didn't have any issues with that, but again, we were concentrating prototyping of the 2 features only, NUMA, pinning, and the huge pages. And the reason we chose those 2, because as we looked at what is happening upstream, we saw the SRV and DPDK roles were already created, so we figured out we don't need to create them right now. We'll eventually converge on the probably the Queen's time frame on OSP 13, which is the next long-term one, and figure out what are the things which we needed to add. New environment file, so I'll skip that. So for each of the features, and we had only 2 here, we created a separate service following the model. I'll give an example of the actual configuration file. And then we composed those services into the single role. As I mentioned, we created a Puppet manifest for each of the services which we created, and then the hit templates which will be driving those. Similar to how various other things have been done, and we created the configuration file which hierarchy is driving, so it's post-deployment steps. So here is a kind of example of what the environment file would look like. So 2 services defined on the top, one for huge pages, one for NUMA, and here is the default parameters for each of the services defined. We decided we created for 3 nodes. Actually, we can decide how many nodes, and it's configurable. And here is the default configuration which we set up to. One of the ideas which will probably extend it in the next generation, those are defaults. Once you do ironic runs a discovery and you find all of the node types and you figure out what are the how many CPUs you have on various nodes, how many pages you have on various nodes and a memory, you probably won't actually go and override those to the configuration you would like to have a node based upon the physical hardware you have discovered. And again, our plan to use Jetpack for that because it's a very simple mechanism for us. I'm not quite sure if, in generically how would, through the TripleO or any other mechanism in existing code base, how to do that, because you have the pieces which are available in one place, but there is no mechanism to take advantage in another place. I would expect that will be not just applicable for NFV, but for other optimized configurations. So I'll probably try to skip most of that stuff. The only thing to mention here that we use a standard hierarchy and the node extra configuration post configuration once node is deployed, how to configure the node for the role. We tracked the database, again, so we know which of the nodes have the configuration and making sure we have the latest configuration. And that's primarily when we start playing with it, people start modifying the features, trying to understand what is the best from the performance point of view, the optimization. And specifically, as we start looking one step further, as Chris mentioned, we have a variety of different VNF modules on top of that. And it's not clear to us that you would actually have the same configuration of the underlying infrastructure to be optimized for that. And the idea was that, okay, you might want to change the configuration of specific infrastructure based upon the benchmark and some other thing to do, and then you'll have to go and modify it. But that's dynamic. So now when you're running one VNF, you will have one configuration, and you run another configuration, another configuration. Well, you have to have a database to know where those stuff is right now. And again, we looked at the ability to extend either TripleO database or the Ironic database and decided that the cleanest way is to have a separate database for the kind of workload above that. And that's why we create database within the auspices of the Jetpack. And that kind of allows as a tracker of the feature. I'm just going to give you the example of the feature, the database. The database is per feature. Saying, here is all the information of what the configuration looks like, with a pointer back to the Ironic, so we know what is actual configuration on node where it is deployed. So it's a relatively simple schema, followed all of the other models we had in the OpenStack for that. So when we did the automation, as I mentioned, we did only the partial of those. You can, of course, add them right to the base configuration, and if you don't turn them on, then they don't have any impact on your current configuration, so they're not used. And as I mentioned, we picked up some subset of how which of the CPUs you'll be pinning, which flavors to use based upon the VM size. And this is based upon the experience we had for running that. And as I mentioned, you can override them, and you can turn them on and off as depending if you're running that workload on the nodes or not. I'll skip the workflow which is happening for each one of those. The deployment of that, we use the current TripleO deployment scripts. We're just passing additional ini file for our stuff, and it runs the entire thing as before. And similarly, we have done for the update. You will see some additional parameters because our solution have the Ceph in it, and we have the Red Hat storage center as a part of the solution. So that's additional parameters we already passing before, so it appears here too. This is the same configuration file I mentioned to you. We created a new name for the role, all of the default configuration we had, plus 2 more services which we added, and those are the registry file with same configuration parameters before. I'll skip how it's working. For the UOI, as I mentioned, we created a new role. We call it Dell NFV. Right now, nothing is assigned to that role, but thanks for all of the work which have been done. As soon as we put in the ini files, it's all exposed. So let me skip all of this, how the UOI is working, and jump to the conclusion slide. So in order to have your solution optimized for a specific workload, you need couple of things. So first of all, you need a partnership with both hardware and software vendors, because you need to have the optimized configuration for hardware, kernel, and software to take advantage of that. Next, you need to have appropriate tooling, so you'll be able to do that in automated fashion and extendable fashion, and minimize risk of doing the work. And look for the partners like Red Hat and Dell EMC who provide you the value for your workloads. Stop at this and ask any questions. Go ahead.
I just wanted to say one thing, which was that in the hype release of TripleO, we actually implemented a derived parameters feature, which I think will satisfy the use case you described, where you need to dynamically generate those lists of CPUs based on the introspection data.
Mm-hmm.
And so when you rebase to the hype release and beyond, you may be able to replace some of the Jetpack calculation layer.
Perfect. Yeah, the goal, the Jetpack is kind of scaffolding to us for do the work, right now. And the more we can land back into the OpenStack actual code base, we'll do that as we go. But again, that was specifically to deliver the current solution, which is OSP 10 base, and we didn't have too many options. Thank you. Yes, John?
What is the relationship between your vCPU pinning and the physical cores? Are you still able to over-provision?
Yes, you are able to over-provision. That brings to the question, what is a guarantee you would like to provide for the various VNF functions? That we can, based upon the pinning, we can control what the numbers are, but we have not exposed it to change it dynamically based upon the load. We only do it as a part of the initial configuration. I guess this is a, if we have the third partner from the, one of the telcos who would like to go one step further with us and figure out what is the actual optimization for specific NFV modules are, then we can pin those things precisely.
How do you do network configuration?
Sorry.
How do you do network configuration?
So we have not actually, since for the two things which we have implemented were huge pages and NUMA pinning, we didn't need to change any network configuration. But for the stuff which for SRV and DPDK, this is part of the existing configuration, which already exposed through TripleO. So I expect that when we get to that, we'll not need to do anything. The configuration, the neutron configuration, which of the OVS or VN or any of the third-party components are standard configuration, which comes with the any parameter TripleO to say how the OpenStack is set up. If we have not found any specific extension we needed to do for that, if you think there is some specific use cases we need to do, we can do that. We did have a couple of the extension to the network which we have done before, and that is for DPDK and SRV for that matter. We have a separate set of the dual NICs which are dedicated specifically for the neutron traffic, for the both for the floating IP and the fixed IP outside of all of the infrastructure one. Yeah, absolutely. Yeah.
How about the rebooting installation?
Sorry.
The rebooting the installation of the also I'm assuming that you have to apply some kernel parameters and so on.
Well, so that's, we de facto apply all the kernel parameters before we do all of the post configuration. So all of the actual configuration of the OpenStack happening after we change the kernel parameters. And we do the reboot of that, so we have to wait appropriate time. This is not fully automated yet. That's why I was asking, is that the better way of doing that, or a better way going and taking the under cloud image, changing that so those kernel parameters turn on and then deploy from there? We can do both, but I don't know what is more supportable in the field, and what is more the right way of doing it when you have more and more roles.
We had that discussion before with Arcady. Like in general, what we see in the field, like we try to avoid modifying the image itself, due mostly to the upgrades, right? So you want to make sure that you don't run in some sort of snowflakey situation, right? So including the configuration change in something like the heat templates is the preferred way. Again, if you're going to roll into the major upgrade for the next release, you have to remember about putting all of the changes you did into the new images.
So just to clarify, from Pipe, there's a new hook in the heat templates called pre-network extra config, and that is a good time to, if you need to install a new kernel and then reboot. There are some examples in the TripleO heat templates tree in recent releases which show how to do that. So yeah, that may be a way.
Excellent.
Good.
Yep.
I didn't quite hear what you said, Mark, we were repeating it, but you can actually do the kernel changes everything on the first boot that hooks into it. So you only need to boot the single time that direct the TripleO does it anyway, so you don't need an additional reboot.
No, it'll be good.
Or then in terms of the kernel tuning and things like that, you can do them as part of the first boot process when the image is pushed up.
The image pushed up.
And then there's only the boots that once you pass it through anyway, and you don't need to do a second reboot for your tuning.
So yeah, if you give us a pointer how to hook it up properly, so we don't have to get rid of all of those kernel configuration window step, will be great. Thank you. Right.
No more questions. So thank you so much for coming.
Appreciate.
We really appreciate it. Thank you.
Thank you.